Hey y'all, it's your math teacher, Mr. Boyden, back at it again. And today we're going to be looking at applications of geometric series. And so where we're going to start today is by looking at money. Now money is by far my favorite application because it's kind of like a way of making gift cards that are good anywhere, right? So it's kind of a cool application. So let's start with this one. Let's say we have just $100, it's in a checking account, and we have it down at the local credit union because at this moment in history, they're getting better interest there than at banks for savings accounts. So at ours, pretty good. We're going to get 6% interest. So first question, how much money are we going to have after 1 year? Now guys, this one's probably the easiest one here. How much money after 1 year? If you gain 6%, a lot of people in class say, hey, 6% of 100 is $6. So you end up with $106. That's totally true. Let's make sure we understand the calculation that leads to it. So all you would do is you would take that 100 and you would multiply that by 1.06. Okay, now some people say, wait, I thought it should be 0.06. It's 6%. Absolutely, but if we multiply by 0.06, that'll just get us the $6. The 1 is saying, hey, we're going to keep that initial $100 and we're going to tack on the extra 0.06, so $106. All right, so that's 1 year. What about after 2 years? How much money would we have then? Okay, well, how we figure that out is we take our $100 and we would multiply it by 1.06, but it's 2 years now, so we'd multiply by it twice. I could write it again, or I could write that it's squared. And that is $112.36. Okay, now some people say, wait, well, that's still basically about $6. It's really close, but there's an important distinction here. At first, we gained $6. Now we gain $6.36. It doesn't seem like it's a big difference, but just watch what's going to happen in these next two. Okay, after 3 years, same thing. 100 times 1.06, except now we're going to do it 3 times. And now we have $119.10. Okay, but what about after 30 years? If we just leave it there, like let's say that, maybe you're in high school right now and you're 18 years old or 17 years old and you got a job and you stuck $100 in there and you just forgot about it and you didn't even realize for 30 years it was there. Well, you could check back when you're 48 and let's see how much money you'd have. You'd have the initial $100 and it would have compounded 30 times. So let's see what that is. Okay, when I do that, I get $574 and 35 cents. Okay, so that's actually quite powerful. And some people say, well, wait, you only got, $474 and 35 cents. Well, yeah, that's true. But the thing is, we only spent $100 to get that. I mean, what did we have to do to turn our money from 100 into almost $600, almost 6 times as much? All we had to do is not spend it. We just had to leave it alone and it grows. So that's an important lesson. That's something that we can harness. Rather than spending every single dollar we make, we have the option to have it grow. So now let's look at another example that many people with careers are using. Some don't even know it, they're automatically enrolled, but let's look at that now. So when you finish college, if you're college bound, or if you start a business, or when you get your first career type job, one of the things that's going to happen is they're going to ask you if you want to start your 401k or 403b or something like that. For my money, it's probably a good idea to do so because you can harness that compound growth, that compound interest that we were just talking about. Let's look at an example. Historically, US stocks have returned about 10% per year. Let's go back and consider that $100 that we have. Okay, that we would have put in the credit union. Now maybe we're putting it in our 403b or a deferred compensation, maybe a Roth IRA, something like that. And guys, you're not going to be tested in my class on those account types. I'm just throwing them out here so that when you get a little older and you hear about, hey, a Roth IRA, that you're thinking, wait, have I heard that before? Did Mr. Boyden mention that? I'm not sure. I should look into that. Okay, so for us, let's say we're going to conservatively estimate 8% growth. Who knows how much we're going to get? The history has been 10. That doesn't mean it's going to still be 10. So we're going to back this down for now. Okay, so how much would we have after 30 years in that scenario? Okay, we'd have our $100 times 1.08 and 30 years. Let's see how much just a 2% change in the interest rate affects the final amount. So $100, 1.08 to the 30th power, that's $1,006. And 27 cents. Okay, so now after only 30 years, our money has grown 10 times. It's up more than 10 times what we started with. That's a pretty good deal. In fact, it's such a good deal that maybe we would want to do that over and over and over again. Instead of just putting in $100 one time, maybe we'd want to do something like putting in $100 every paycheck. Or maybe we would want to put in even a little more than that. So let's consider that now. Okay, for this example, what I want to use is I want to use what you might do in the current day if you wanted to fund a Roth IRA. Okay, now if you wanted to fund a Roth IRA, you might fund the maximum. The maximum amount you can put in, and this is the year 2018 when I'm recording this, okay, the maximum you can put in this year is $5,500. Okay, per year. Okay, and so then let's say that maybe you start doing this when you're 25 years old, and maybe you do this until you're 65 years old. So we're going to be doing that $5,500 a year for 40 years. Okay, and so let's figure out how much money are we going to be investing in this example. So what do we have? We have our $5,500 multiplied by our 40 years. And so what this is going to tell us is how much of our own money did we put into this Roth IRA. So 5,500 times 40. Okay, so over 40 years, we've put in $220,000. Seems like a lot of money right now, right? Now, the reason I bring that up is because we're going to figure out, once we've invested it, how much do we end up with. But that doesn't mean a whole lot unless we have something to compare it to. If we had simply stuck it in a cookie jar or stuck it under our mattress, we'd have had $220,000. Now, there's nothing wrong with having $220,000, but let's understand what happens if instead we invest that money and if we get 8%. Again, 8% is not guaranteed, but if we do, let's see what happens, okay? So let's track the individual dollars. In the first year, we put in $5,500. And it's growing at a rate of 1.08. And how many years does it have to grow until we're going to take that money? Well, in this example, 40 years. So we're going to say that's to the 40th power. The next year, we put in another $5,500. And that also grows at the same rate. But how many years does this one have to grow? It doesn't have 40 years because we're putting this money in a year later. This is year one's money. This is year two's money. So this money only has 39 years to grow. Okay, what about the next one? The next one only has 38 years to grow. The one after that, 37, 36, 35. So we can see we have a pattern here. Now this is why it matches up with what we've learned about geometric series. We have an exponent that's counting either up or down, and we're adding up all those terms, so that makes it a geometric series. So rather than writing out all the terms, I'm going to just skip to the last one, because we can see the pattern now. So in the final year, we put in 5,500. It grows at a rate of 8%. And how many years does it have to grow? It grows just for 1 year. Now, we want to add up all of those terms. So what I'm going to go back to is what we learned about geometric series. That was a sub 1 times 1 minus r to the nth power, divided by 1 minus r. Okay, so let's plug in what we know. So first term, this is the one that tricks people a little bit. So, so what we have, this looks like the first term, but remember the first term typically is the one which has an exponent of 1 or 0 on it, and then the exponents count upward as we go through the sequence. So actually this down here is going to be my first term. So let's write that in. That's 5,500 times 1.08. I'm not going to write to the first power because it's implied if it's not there, so I'm going to leave that alone. Okay, now I'm down to this 1 minus r to the n stuff. 1 minus, remember r is the thing we're multiplying by, that's 1.08. And that goes to how many terms there are. There's 40 terms here because we're doing 40 years. Divided by 1 minus r, and r for us, again, that's 1.08 still. So let's take a minute. It would probably be a good idea if you also practice typing this in a calculator. So 5,500 times 1.08, and then you really need to be careful with your parentheses here. So 1 minus 1.08 to the 40th, Make sure you close those parentheses before you do that denominator. And then I realize I probably need to actually write in the decimal there like a good mathematician would. So divided by 1 minus 1.08. And then hold on to your hats, because how much money do we have? At the end of this, we have 1,538,795 and 72 cents. So we took our $220,000 and we turned it into 1.5 million. That's a pretty good deal, folks, okay? So you don't have to do this, but I think it's one of those things that it's important that we learn in school what options we have in life. Knowledge is power, right? So we've now learned that if you want to put money in a bank, there's nothing wrong with that. You will end up with money saved, but you can also invest that. And in this particular example, you end up with about 1.3 million extra dollars that you'd not have had otherwise. So kind of a cool deal. Hope you enjoyed today's video. Maybe this concept of investing and having your money grow is new to you, and seeing that compound interest can be kind of exciting. So again, hope you enjoyed it, and we'll see you again next time.